I am Anil Kumar. Welcome to my series on solving problems from IBHL past test papers. You must have seen many solutions by now. The only difference here is that we are getting into understanding a question completely and connecting all the concepts which could be applied in solving such a question. At the end of the video, you'll have a lot of learnings to take, and these learnings will help you score very good marks in your own test papers. That is the reason why my students actually score excellent marks. So this question, many students found it difficult. I got requests from some of them. They need the solution with understanding of what is going on here, right? Well, the question here is, the diagram below shows the graph of function y equals to f of x defined for all x belonging to real numbers, where b is greater than a, which is greater than 0. So that's the parabola drawn. A on the x-axis, b is a y-intercept, minus a and plus a are the x-intercepts. The question is, consider the function of g of x 1 over f of x minus a minus b. Find the largest possible domain of function g. So this statement, largest possible domain of g, where g is a rational function, in itself seems to be simple but confusing, right? Part B is, on the same axis below, sketch the graph of y equals to g of x. On the graph, indicate any asymptotes and local maximum or minimum, and write down their equations and coordinates. Very important. So when you read the question, you should understand completely what all should be covered in the solution, right? So equations, coordinate points, everything is required, right? Now let's try to understand this situation first, and then we will answer. Okay, so this statement, which is all are positive, a, b are positive, and b is greater than a. What is b? First thing, what is b? So let's try to relate it, right? So we can say for sure that the value of the function at a is actually b. You get the idea. And also the value of function at minus a is also b. So we can clearly see that we have an even function. Do you see that? So these are two critical things which you get from the figure itself. Now, if you get this idea, then part solution is there with you. Perfect. Now we need to consider g of x. And what is g of x? G of x is equal to reciprocal of, that means 1 over f of x minus a and then minus b. We need to find the domain of this function, correct? So domain means that the denominator, that is f of x minus a minus b, should not be equal to 0, right? So to find the domain, you have to really figure out where is f of x minus a equal to b, because those are the restrictions, right? Not equal to 0. You get the idea. So this results into our solution. How? Let's try to see, right? So what does that imply? That means that f of x minus a should be equal to b, right? So that means restrictions. Makes sense, right? Now, what is f of x minus a? F of x minus a, let's try to understand this part, means the graph of f of x, which is given to you. Let me write down the equation given to us as f of x, and now we're looking into f of x minus a. X minus a means that f of x is translated a right, a units right. Makes sense, right? So basically, the whole graph will move a units right. So if you move every point a unit right, then what happens? This point, which is at 0, comes to a, right? Correct? And therefore, you have the graph of the function as this. That is f of x minus a. Correct? It moved a units right. Now what you need to say, so this is your graph. Correct? Let me write f of x minus a. Now you have to find where is this equal to b. So let me extend this line y equals to b, right? What do you notice? Well, clearly, in the new graph, it intersects at 2 points. So these are the 2 points where f of x minus a is equal to b. Can you tell me what are these points? Well, clearly these points are 0 and 2a, right? Because you moved by a units to the right. You get the idea. And therefore, we have 2 restrictions, and that is domain of f of g of x, which is 1 over f of x minus a minus b. So the denominator is 0 for x equals to 0 and 2a, right? Is x belongs to real numbers where x is not equal to 0 and 2a. Is that clear to you? Perfect, because the function actually moved 2 units to the right. And then you will see that f of x minus a will be equal to b, correct, at x equals to a and 2a. You get the idea. You can check, right? So you can check that g of x is equal to, if I replace x with 0, then what happens? F of minus a minus b, right? So this is not defined, right? Because f of minus a is b. So we get b minus b in the denominator, right? Similarly, we could also write g of 2a, right? Will be what? 1 over f of 2a minus b, which is also not defined. Because you get 2a minus a is f of a, right? So let me write down this as 1 over f of a minus b, correct? Which is also not defined. So those become the restriction, and that is how we are going to find solution of part A. Is that part clear to you? So very beautifully, I have illustrated here why the solution is for this, that x is not equal to a and 2a, right? So many of you have seen the solutions and answers. You know the answer, but reason it out and correct it so that in future you can also provide the correct solution when a new question based on this concept appears. Perfect. Now with that, let's move on to part B, which is On the same axis below, sketch the graph of g of x. So we'll sketch the graph of g of x, right? So let's move forward. Now here, our focus will be to graph g of x, which is given to us as 1 over x minus a minus b. So to graph g of x, what we need to do is first we will graph f of x minus a minus b. So let me use a different color. H of x be equal to f of x minus a minus b. So what does that mean? We are going to translate the function a units right and b down, right? So that means translate a right and b down. Make sense? So if I translate this a right, then the function will be, as we saw last time, when we are dealing with the domain of the function. And now b down, right? So if I do b down, that is b, right? So let me just extend the x's. So if I bring all the points down by b units, then you can see that the point here comes down to b by, it will be right there, correct? And so this point which was at b will come to this point, correct? And therefore you'll get a parabola which is being drawn in solid. Okay, let's do a better job. Okay, so that is the h of x, right? Now once you have this function, then what are we going to draw is a reciprocal function, right? So now what is g of x? G of x is basically 1 over h of x, right? Is that clear to you? So we are going into stages, and then we are going to answer all these questions, which is indicate asymptotes, local maximum minimum, and write down equation of the coordinates, correct? So when you pull it down by b units, this point is minus b. You get the idea? These points are 0 and 2a, correct? Right? Axis is at a. So we have vertical asymptotes at 0 and 2a, which are restrictions on the graph. So let me draw that. So this is x equals to 2a, a vertical asymptote. And here also, we have a vertical asymptote, which is x equals to 0. Get the idea, right? Now the point which was the local minimum on our h of x will get reflected, will be 1 over b, right, minus b. So this part of the graph is going to be kind of like this, symmetric about this particular line, and the point here will be the local maximum, which will be at a minus 1 by b. Makes sense, right? Reciprocal of minus b. So we have coordinate point of the local maximum, correct? Now, wherever you have on this function, let's say b is somewhere, 1 is somewhere in between, right? In that case, the graph on the right hand side will be like 1 over x, right? And on the left hand side also will be like 1 over, and symmetric. Do you see that? And these points where they intersect will actually be the value where the function value is 1. You get the idea. So these invariant points are where the y value is 1. Correct? So with that we have our final graph, right? So indicate any asymptotes. We have indicated both the asymptotes, and there's one more here, which is y equals to 0. Do you see that? So we have a horizontal asymptote. Many students might miss there, right? Both sides, correct? And local maximum or minimum. So we have a local maximum, right? At A, value is minus 1 over B. And write down the equations and coordinates. So equations of vertical asymptotes we have given, right? Horizontal asymptote we have given. And we have also given the coordinate points for the local maximum. Is that clear to you? Perfect. So that is how we are going to solve this particular question. So I hope you have understood all these strategies, right? Have a good look at the solution. Let us summarize what we did here. So the summary is that we are given the function and we need to figure out g of x, which is 1 over f of x minus a minus b. So that means f of x minus a minus b is not equal to 0, right? Since we know that f of a equals to f of minus a, which is b, and therefore x minus a should not be equal to either a or minus a. Do you see that? And that results into x equals to 0 and 2a. You get the idea. Another way of looking at it. Perfect. So we got part A saying that x is not equal to 0 and 2a. But x belongs to all other real numbers. For part B, this was part A, and for part B, what did we do? We actually first identified another function, which is the denominator here, right? That means translation A units to the right and B to the down, right? So that means the axis came to this point, right? And we have a graph which is like this. And you can very clearly see this point was 2a, right? And then we actually from here figured out h of x, which is reciprocal of h of x, right? G of x, right? Drawing vertical asymptotes at the zeros of denominator, right? And flipping the lower half, knowing fully well that this point now will be at min a minus 1 by b, right? Since this local maximum was at minus b, you moved it b units to the down, correct? And the right and left side of the graph will be kind of like this, like 1 over x, right? Horizontal asymptote being y equals to 0, vertical asymptotes being x equals to 0 and x equals to 2a, right? And local maximum being at a minus 1 over b. So that is the summary of our learning. Perfect. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. In case you want to learn from me directly, you can always send an email on the address given. Thanks for your valuable time and all the best.